Hi everyone. In the last session, we discussed about how to implement the programs to print the elements of two-dimensional array in matrix form. And we discussed how to find out the row sum and column sum of a given matrix. I have explained the coding part of both programs. If you have further doubts, if you have any doubts still, so I will clarify those doubts by explaining theoretically. So we will see how we have to write the code to print the elements in matrix form and how to find out the row sum, column sum. After that, we will see how to add two matrices. Next, how the matrices can be multiplied. So let us see one by one. So first, we are going to discuss about how we have written the program to find out the row sum and column sum of a matrix. See here, whenever we use the concept of two-dimensional array, we are declaring the array like this: integer, some array name I'm taking A, and assume that I have taken 5, 3. Two dimensions I have taken. This is the two-dimensional array. And we know that, so we have used how many for loops? Two for loops. So to read the elements into two-dimensional array, we have used two for loops, right? So generally, we are declaring two variables, integer I comma j. This is a rough code I'm writing, right? I comma j. After that, what we say generally for I equals to 0. Why? Because the starting index or the counting of elements of an array starts with 0. So that's why we are saying I equals to 0, and we say I is less than 5. So the dimension I'm taking here 5. Next we say I plus plus, and next we say for j equals to 0 and j is less than 3, j plus plus. After that, we have used the scanf statement percentage %d double quotes close ampersand a of ij. So this is the logic we have used to read the elements from the keyboard, right? See, the same code can also be written like this. Already I said for I equals to 0, I is less than 5, I plus plus. Next, you can write here opening brace for j equals to 0, j is less than 3, j plus plus, opening brace. Here you can write scanf percentage %d double quotes close ampersand of a of ij, ampersand of a of ij. Here you can write closing brace here and closing brace. So this code is same as this. These are all same. Okay, but the thing here is, here I have written opening brace, here I have written another opening brace, two opening braces I have written and two closing braces I have written. Why? If I write opening brace and closing braces like this, you can easily understand how the statements will be executed, right? See, so instead of writing more number of statements by writing opening brace and closing brace, better to prefer this once you got the concept, right? See here what happens whenever we say integer a of 5, 3, I said that 15 memory locations are reserved, and we will be reading how many elements? 15 elements into this array. See, whenever we say integer for a of 5, 3, I said the memory is created like this, okay, and so on. And the elements are given as first subscript we can given as a of 0, 0. Already we discussed here. The first subscript is a of 0, 0. So what is the subscript? So whenever we say integer a of 5, 3, okay, well, so we are going to have the memory representation like this. Better to understand each and everything in clear. 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13, 14, 15. So these are the 15 memory locations that are reserved, and every memory location is having address, right? 100, 102, 104, dash, dash, okay? So like that we are having the addresses. Why 100 and 102? Why? Because when an integer takes 2 bytes of memory, so the next address will be 102, okay? If it is 4 bytes, then 100, 104, 198, so that you remember. So once you say integer a of 5, 3, memory is reserved like this. All the memory locations are reserved this. Total how many elements are there? 15 elements. So 15 into, if it is going to take 4 bytes, we write 100, 104, 108, like that, the addresses will be given. So if the integer takes 4 bytes, 15 4 ja how much? 60 bytes of memory is allocated for this, right? And the first one, the first location is represented as a of 0, 0. Please remember this. This is a of 0, 0, and second one is a of 0 1, and this is 0 2. I'm not writing a, just please understand, no space. This is 0 0, and this is 0 1 0 2. Next, what you say, 0 3, and this is 0 4. So after 0 4, what happened? 0 4. So here first subscript 0 is common here. Okay. Now we have 0 0 0 1 0 2 0 3 0 4. Okay. Next, what you do? 0 1 0 2 0 3. Total how many elements here? 15 elements, right? 5 3 meaning is first you take this is first you take 5. 5 means a of 0. See how to divide this. Whenever we declare like this, first dimension you take a of 5. A of 5 means we write a of 0, a of 1, a of 2, a of 3, and this is a of 4. We have to write this is the first dimension. Now after dividing this, now each is divided into 3 parts. Already I said, no, second dimension is 3. This we call it as a of 0, and this is a of 1, and this is a of 2. So each one is again divided into 3 types. This is a of 0, a of 1, and this is a of 2. So and so on. So like this, what you say? The first element is, so you see 0. Here there is this we read a of 0 of a of 0. It means it is indicated as a of 0 0. And next this is a of 0 1. Next a of 0 2. Okay. Now what you would write? A of 0 0, a of 0 1, and a of 0 2. Up to this you write a of 0 2. Now second one, a of 0 0, a of 0 1, a of 0 2. Next, what you say? Here you have to start from a of 1 0, a of 1 0, and this is a of 1 1, and this is a of 1 2. So this. Now next, after a of 1 2, next we have to write 2 0, 2 1, 2 2, 3 0, 3 1, 3 2, 4 0, 4 1, 4 2. 4 2 in the sense we have to write it as a of 4 2. These are the subscripts by which we can access the elements. These are the memory locations. See here, this is one part, 3 3 I'm dividing. This is the second part, and this is the third part, and this is the fourth part, and this is the fifth part. First part, second part, third part, this is fourth part, and this is fifth part. So here 5 parts are there, means this indicates the 5 part. One dimension is 5. 5 means we write 0, 1, 2, 3, 4. 0, 1, 2, 3, 4. So this is in 0, we have again 3. That means in 0, we have again 3 memory locations, right? So that we call it as 0, 0, 0, 1, 0, 2. That means a of 0, 0, a of 0, 1, a of 0, 2. Here, in this case, this is 1, no? 1, in this case, again 3. 1, in 1, we have 3 locations. That means 1, 0, 1, 1, 1, 2. Here it is 2, 0, 2, 1, 2, 2. So, like that, the subscripts are given, the names, the references or subscripts are given to the two-dimensional array. Now, assume that, so by using scanf statement, just now we have written, right? So here what we have written, we have written scanf statement, right? So for I equals to 0, you see here, first we have reserved 15 memory locations and I have named like this, no? So after this, what we are going to do? So we want to read the elements, how many elements? 15 elements. How to read the elements? We have written this code, right? So I equals to how much? 0. 0 is less than 5. Yes, the condition is to then go to second for loop. J becomes 0. 0 is less than 3. Yes, again go to scanf. This scanf statement is executed. So this scanf statement reads the value. Assume that in yesterday's program we have pressed 1, right? That 1 is read into ampersand of a of 0 0. Means the first address memory location we have given 100, right? Like here we have given 100, right? So into 100 we are reading the element 1. Okay. Next, next after reading this semicolon is there, right? So this semicolon, what it is going to do, it sends the control to the inner for. Inner for means j for loop. So here j value gets incremented by 1, so j value becomes 1. After becoming 1, the condition is tested. Now j value is 1, right? 1 is less than 3. Yes. Again, this scanf statement is repeated. So now we are going to read the second element. What is the second element we want to read? Assume that we have read 2. 2 is read into second memory location whose address is 104. After that, what happened? Now again semicolon. Now j value is incremented by 1, 2. 2 is less than 3. Yes. 2 is less than 3. The condition is true. Now again we are reading the element. Scanf statement is executed again, and assume that we have entered the element. The element is 3. We have read the elements, right? After that, again we have semicolon. Now j value becomes 3. So 3 is less than 3. No, condition is false. When the condition is false, what happened? The condition goes up to first for loop. Here I value becomes 1 now. I value becomes 1. Previously first time 0, now I value becomes 1, and 1 is tested here. 1 is less than 5. Yes, the condition is true. Again it enters into this for loop, and j value again starts from 0, and it is repeated again 3 times. So like that, so it is going on reading 15 elements. So final value of I becomes 5. In this case, the condition is tested. 5 is less than 5. No, condition is false. When the condition is false, the first for loop is not executed, second for loop is not executed, and the scanf statement is also not executed. Since the code of these same explained like this, you see here. So if you see this code by writing opening brace and closing brace, it is very easy to understand how first I value becomes 0, 0 is less than 5, yes, and we are entering into this block, j equals to 0, yes, 0 is less than 3, we are entering into this block, scanf statement is executed, we are reading the first element, after this block we are going to j. So okay, so it is repeated. So when j value becomes 3, 3 is less than 3, no, in this case this scanf is not executed, we are going to this closing brace. This is the closing brace for whom? First for loop, and it goes to I plus plus. So same scenario. But for your understanding purpose, I have written opening brace and closing braces. So this is the way of reading the elements into two-dimensional array, and assume that we have entered the elements like this: 4, 5, 6, 7, 8, 9, 10, 11, 12, 13, 14, and 15. So this is the way of reading the elements into two-dimensional array. So after completing this, what we have done this, we have printed these elements. Actually, the elements in the memory are not stored row by row. All the elements are stored only sequentially like this. There are no rows, there are no columns. There is only one row in which all the elements are stored. It may be two-dimensional array or three-dimensional array or any dimensional array. All the elements are stored. So some of the teachers will say that also we have rows and columns like matrix. No, the memory is only stored. The memory is allocated sequentially in contiguous memory locations. The values are stored. The memory is allocated. But for our convenience, we are saying that there are some rows and columns. So we are retrieving the elements of two-dimensional array, and we are printing those elements in row and column wise. That is the thing we are going to do. So in the yesterday's program, so after reading the elements into two-dimensional array, we have printed the elements into matrix form. How we have printed the elements in matrix form? See, we have given the elements like this: 1, 2, 3, 4, 5, 6 up to 15, right? So what we want to do is we want to print the elements like this. How we want to print the elements? We want to print the elements like this: 1, 2, 3. I think how many, what is the first dimension? 5. Okay, 5. So there are 5, 5 dimensions, 5, 3 is 15 elements, right? 1, 2, 3 for the first part and second part, right? Right? This is the first part, 1, 2, 3. Next, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13, 14, 15. So like this, three columns, 5 rows. 5 rows and 3 columns. Like this, we want to print. 5 rows, 3 columns. Like this, we want to print. So this we call it as in matrix form. So how to print the elements like this? See, we know this is 0, 0, right? 0, 1, 0, 2, right? And next we call it as 1, 0, 1, 1, 1, 2. Okay. This is 2, 0, 2, 1, 2, 2. And this is 30, 31, 32. This is 40, 41, 42, right? We know the indices. So we want to print the elements like this or subscripts. We know that these are the subscripts values. So we want to print the elements of this one row in how many rows? 5 rows. How to print? So we want to print some spaces in between the elements, right? 1 space, 2 space, 3. So if you see this matrix form, we have some space, right? So how to print the elements like this? For this, we have written the code like this. for I equals to 0 and assume that I is less than 5 I plus plus, and we have written opening brace for j equals to 0 and j is less than 3 j plus plus, and after that here we have written printf statement. Here I have written percentage d and slash t. Here a of ij we set. Okay, after this we have written another printf statement slash n we have written, right? Slash n, and this is the code we have written in yesterday's program to print the elements in matrix form. So here what happened? First I equals to 0 and 0 is less than 5. Yes, the condition is true. Now we are entering into the for loop. J equals to 0. Yes, 0 is less than 3. Yes, the condition is, we are printing this printf statement. This printf statement is executed. Percentage d is the value. What is it? It is the value of a of 0 0. What is the value of a of 0 0? 1 here. Now we are printing 1. 1 is printed, right? After this printf, what happened? The cursor is not going to the second printf, right? After this semicolon, the cursor goes to only this j plus plus part. Please try to see this semicolon send the control to j plus plus, and j value becomes how much? 1. Now the condition is tested, 1 is less than 3. So when the condition is true, again this printf statement is executed second time. Here after printing 1, so see here previously we have printed 1, right? After printing 1, which is the value of a of 0 0, we have written slash t, means we are getting this space, right? Now second time j value becomes 1, 1 is less than 3. Yes, we are executing printf. So it is the percentage d is the value of I value how much? 0 only. J is 1. A of 0 1. How much a of 0 1? This is 0 1. How much 2? 2 is printed here. Okay. 2 is printed. After printing 2, we are getting space, 3 spaces, that is slash t. Okay, 3 spaces. Now semicolon, again we are going for j is incremented by 1, j becomes 2. Now 2 is tested here, 2 is less than 3. Yes, the condition is true. Again this printf statement is executed. Now it is going to print the value of a of 1 2. What is the value of a of 1 2? A of 1 2, you see here, a of 1 2, this is 0 0 0 1 and this is 1 2. 1 2 or 1 0? A of 0 2. This is 0 1 0. 1 minute. Here what we are printing, j value how much? 2. 0 2. Okay, 0 2. We are going for 0 2. 0 2 is 3. See here, this is 0 to 3. Now we are printing 3. 3 is printed. Now again semicolon, go to j plus plus. J value becomes 3. Now 3 is less than 3. No, condition is false here. When the condition is false, the cursor goes to, sorry. When the condition is false, what happened? The cursor goes to second printf statement. The cursor not, the control is not passed to this outer for. Why? Because we are in between opening brace and closing brace. See, when the j value becomes 3, 3 is less than 3, no, the condition is false. When the condition is false, this printf statement is not executed. It goes to this printf statement. Okay, this printf. So what it is going to do? It is going to print the slash n. Slash n here, what happened? The cursor remains here. Whenever we execute slash n, the cursor moves to the next line. So we are at this place. Okay. Now after this, this is the closing brace. This is the closing brace of last for. In this case, we are moving for I plus plus. Now in this case, what is the value of I? I value becomes 1. Now 1 is tested here. 1 is less than 5. Yes, the condition is true. Now again we are entering into this loop. So here we are starting from again j equals to 0. And this is repeated how many times? 3 times, where we are going to print 7, 8, 9. So after printing 9, what happened? This j value becomes false, and now we are going for this printf, and it moves the cursor to the next line. So like that, we are going to print the elements in matrix form. I think it is clear to you. So this is the way of printing the elements in matrix form, right? So after that, we have seen how to find out the row sum or column sum. How to find out the row sum and column sum. So we have written that the elements are like this: 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13, 14, 15. This is. So here row sum, how much? 3 plus 3, 6. Here 9 plus 6, 9 plus 6, 5, 4, 5, 9 plus 6, 15. Here 15 plus this is 24, and this is 21, 21, 33. 21, 33, and here it is. So we know 27, 30, 42. Okay, assume that the 42. So here what we are going to column sum 5, 7, 12, 22, 22. This is 35. Here we are going to print 7, 15, 15, 26, 26. This is 40. Here 9, 18, 18, 30. This is we are going to get 45. So like that we have to, this is column sum, right? This is, we call it as row sum. This we have seen in yesterday's program. So how these elements are, how this row sum and column sum will be printed. So we know how to print the elements in matrix form. Okay, we have printed. Now how to find out the row sum and column sum. We know this is 0, 0 and 0, 1, 0, 2, right? This is 2, 0, 2, 1, 2, 2, 3, 0, right? 3, 1, 3, 2, 4, 0, 4, 1, 4, 2, 3, 0, 3, 1, 3, 2. Okay. 3, 1, 3, 2. So these are the indices or subscripts. Now, what you have to do, take the first row only first row. First row, you take this first row. We want first row sum, right? How much? 6. To find the sum of 1, first we have to add 1 to some variable so that the result remains 1. So for that we are going to take a variable that we know sum, and initially we are assuming it as 0, right? Now after first row sum how much? 6. First row how much? 6. Now to find out the sum of the second row, again we need a variable like sum, right? So for second row, don't take second sum, another sum, one variable, sum, two variable. If you declare multiple variables, it is going to take too much memory, right? So what is the use of taking another sum? So better to use only this sum. So after printing the first row sum, so reinitialize this sum equals to 0 and get the sum of the second row, where here the new sum becomes 6. Sorry, what is this? 15. But before going to store 15, you have to reinitialize to sum equals to 0. Okay, now again 15. Now you reinitialize sum equals to 0. Next sum will becomes 24. Next you reinitialize sum equals 0. Next sum becomes sum equals 0. After that 33, sum equals 0. Next 42. So this is the logic we have seen in yesterday program. So what we have done is just we have said that for I equals to 0 and I is less than 5, I plus plus. So within this opening brace, we said that for j equals to 0 and j is less than 3, j plus plus. Here actually no need of writing opening brace, just you write what you do is sum equals to sum plus a of ij, I said a of ij and a of ij, and here we have printed like this, printf percentage d double quotes close sum. After percentage d sum, here we have written sum equals to 0. Okay, closing brace, sum equals to 0. Now see here, in yesterday's program, I think we have written this opening brace here, and it is not required, but we have written opening brace and closing brace. So if you see this, what happened? Now before entering into this for loop, sum equals sum plus a of ij, what you do is you have to declare a variable. So in the after the main, here you declare the value sum and you say sum equals to 0. So here I equals to first 0, 0 is less than 5, yes, enter into this for 0, 0 is less than 3, yes, come to this. Actually this opening brace, closing brace not required. You write sum equals to 0 plus a of I value, j value 0, 0, a of 0, 0 means 1. You see 1. This 1 is added, 0 plus 1, 1. Now again we are moving for the j and we are adding 2. Next we are moving this, we are adding 3. So this final sum value becomes 6. Next j value becomes 3, 3 is less than 3. No, this becomes false. When this becomes false, this sum is not executed. Now we are going for this printf and it prints the sum. What it prints? 6. After printing this 6, we are reinitializing this sum equals to 0. Now we are moving to outer for. Now here j value becomes 1. Now 1 is less than 0, means we are going for the second row. So for the second row, 15 will be printed like this. So like that, we are going on repeating this, and it is going to print first 16, 15, 24, 33, 42. Okay. Now, how to print the column sum? To print the column sum, same thing we have to use. But the thing is, first you write j equals to 0 and j is less than 3. You write this second for loop first and first for second, and you write as it is sum equals to sum plus only ij. So that gives 35, 40, 45. So this is a simple explanation about how to find out the row sum and column sum. So in the next class, we will see how to find out the addition of two matrices and multiplication of two matrices. I think this is clear for you. This is the only theoretical explanation of the previous two programs. If you have any doubts, you can comment. So with this, I'm going to close the session. Thank you for watching.